today we're going to finish up our notes that we left off on yesterday. So let's backtrack to 3B because I think we skipped that. What we're going to do is we're going to start with the more complicated side, which I would say is this one. And what we're going to do is we're going to try to break it down. And let's break it down in the sense of let's change everything into sine and cosine. So secant can become cosine, or 1 over cosine. So in the numerator, I'm going to put 1 over cosine squared x. That's the numerator. Now, in the denominator, tangent becomes sine over cosine. And if you recall, again, a lot of this comes back to, do we remember our algebra skills? If we are dividing by a fraction, we will be multiplying by the reciprocal, which is 1 over cosine squared x, and the reciprocal would be cosine x over sine of x. And hopefully you see something right away. You can see that this cosine right here cancels the 2 down here. So what we're left with, and I did run out of room, but what we're left with is 1 over cosine x times sine of x. And sometimes I like to work off of both sides of the equation. Secant becomes 1 over cosine x. Cosecant becomes 1 over sine of x. And we can kind of put that together. And you see then they are verified with each other. Now, some of the problems do amp up a little bit. As you can see, this is a little bit more complicated. Really, one of the big things is to try to remember all of your algebra skills. So when we look at this one, let's start with the more complicated side, which hopefully makes sense, which is the left side. And you'll notice it's 2 fractions. Algebra skills, again, we want to bring together the 2 fractions, and we do that by making a common denominator. So I'm going to rewrite it so that we can see what we're going to do. And I'm going to leave some space here, okay? And in order to create to bring together the terms, we need a like term, or like denominator. So over here on the right, one of the denominators is cosine x. And then this one over here is sine of x. And so in order for them to have a common denominator, what needs to happen is that I need to multiply this side by 1 minus sine of x over 1 minus sine of x. Okay? And then over on the left side, I'm going to multiply this one by sine of x over sine of x. Now compare the two. You can see that on the right side and the left, they both have the same denominator. If they have the same denominator, I'm going to make one long one. And I made a mistake. Hopefully you guys caught that. It shouldn't be, this should be cosine of x. So let's fix that. Sorry, cosine of x. Now they should match. Now, what's going to happen is I am not going to factor the denominator. And I'm going to keep it as cosine of x times the quantity 1 minus sine of x. Now, when I go to bring together the numerator, cosine times cosine is cosine squared x. And what I'm going to do right here is I'm going to change this minus to plus a negative, and I'm going to distribute the negative sine of x. So it becomes minus sine of x plus sine squared. So again, what I'm doing is taking this, multiplying it by the 1, taking this, multiplying it by the sine of x. So now look at the numerator. Is there anything that looks familiar from the numerator? And hopefully there is. Do you notice that there is cosine squared x plus sine squared x? That's a Pythagorean identity. It says that sine squared plus cosine squared equals 1. So what we're going to do is we're going to replace that with 1. So 1 minus sine of x over cosine x times the quantity 1 minus sine of x. And hopefully you see this as well. 1 minus sine of x cancels. So we have 1 over cosine of x. Now the secant, I'm going to work off the other side, or I could change that to secant, becomes 1 over cosine of x. So I'm just going to remind us that I don't want to say the problem, the kind of the neat thing about verifying trig functions is that you might do it in a different way than someone else, but you both can be right. So if the way we approach something, you think, hey, well, couldn't you do this? Most likely you probably can if the algebra holds strong. But this is just how maybe I approach it. So what's going to happen with this is I see this problem right here, and there's one thing that I want to kind of sidetrack to. If we think of factoring for a second, if I think of the problem x squared minus 1, and I ask you to factor it, hopefully you will say x plus 1, x minus 1. Or if I say 1 minus x squared equals 1 minus x, 1 plus x. So we factor those. The same can hold true if we say sine squared x minus 1. Or, actually I'm going to change that around, sorry. Let's say 1 minus sine squared x. I asked you to factor it. This factors to 1 minus sine of x times 1 plus sine of x. Now, this technique right here gets used in different ways throughout different problems, taking a Pythagorean and trying to factor it. So that's why I want to kind of introduce it to you guys. So what happens is if we see this right now, this is part of that. 1 plus sine of x is half of that original 1 minus sine squared x. So what I could do is I can multiply by the conjugate. And this is something that's not completely new to you guys. You used to use this for rationalizing and things like that. So I take the opposite. And what I'm going to get in the numerator, and I'm going to leave this factored in the numerator, 1 minus sine of x times, oops, this should be theta, sorry, theta. And in the denominator, when I FOIL, I get 1 minus sine of x plus sine of x over, or minus sine squared, and sorry, I keep switching to x, it should be theta, theta. Now, what do you notice? Hopefully you notice that the middle terms cancel out, correct? And what we are left with is 1 minus sine of theta in the numerator over 1 minus sine squared theta. And that equals 1 minus sine theta over cosine theta. Sorry guys, I forgot the cosine over here. I dropped down the cosine. Now what you notice is that the numerators are almost there, right? They both have a 1 minus theta, so we're getting on the right track. One other thing that comes up a bit is this idea of a Pythagorean identity and manipulating it. Just moving it around, and we saw that with the other identities. So this, if I subtract cosine squared, sine squared x equals 1 minus cosine squared x, okay? So this is equivalent to this. Or what we could do is we could subtract sine squared x. So then cosine squared x would be left by itself, and then it would be 1 minus sine squared x. Well, what just happened here? I figured out this piece. 1 minus sine squared x is equivalent to cosine squared. So in the numerator, I have 1 minus sine theta times cosine theta, now over cosine squared theta. And hopefully you see the cosine and the squared part cancel out. And we're left with 1 minus sine of theta over cosine of theta, which then verifies. Now, again, different techniques for different things. So this is the way I showed you. Part of the reason is I wanted us to kind of see this kind of technique because it does get brought up. I also wanted to see this technique because this gets brought up quite a bit. But an alternative way up here would have been to make a common denominator. Maybe multiply this side by 1 plus sine of theta. And then multiply this by cosine theta over on this side. And then those would have canceled out. And honestly, maybe would have been a little bit faster, just depending on what your preference is.